Hello everyone, this is Mikhail. I'm doing our walkthrough for Lab 8, Terrain Analysis. In this lab, we created a layer that gave us the flood risk for areas in the Salt Lake Valley if the Red Heath Reservoir Dam were to fail. Um, so we created some watersheds, we did an extract by mask. We've also used the raster calculator and a couple other different tools that we used so far this semester. So shouldn't be too bad. Um, but with that said, I'm going to get started. So I've already gone ahead and downloaded and extracted and added the elevation data to my map. And to finish off 1A, we're going to right click on elevation data. We'll export this raster. Let's make sure that this raster is being sent into the correct database. Um, this is my old work through, so this is my old elevation, but I'll save it and export it, and then we can delete the old one. Moving on to number 2. So when analyzing surface water flows, cells lower than all surrounding cells, called sinks, will prevent various analysis tools from working properly. So to fill that in, we're going to use the fill tool. Let's use the fill spatial analyst tools, and we'll select our elevation. This lab does have a lot of moving parts, so I'd recommend taking a second and really giving your output surface raster names logical or names that make sense. But that is our fill. So then I'm just going to deselect the old elevation so we can have our fill elevation up top. Now, to delineate a stream network, we need to calculate the flow accumulation for each cell. Flow accumulation represents the number of upstream cells in a raster that flow into each respective cell. So before we can run the flow accumulation tool, we first need to get the flow direction. So flow direction can be found under flow direction. And we're going to make sure to select the spatial analyst tools right here. Our input surface raster will be our field elevation. And let's, again, take a second and give our outputs a good name. So this is just going to be flow direction. You can leave the defaults for the rest of these settings. All right, we've got our flow direction. And now we want to calculate the number of upstream cells. So to do that, we're going to use the flow accumulation tool. So we can search for flow accumulation. And we have our spatial analyst tools right here. Our flow direction will be our flow direction. And let's again take a second for our output accumulation raster. And we'll go flow accumulation. We don't have our weight raster yet, so we're good to run this. Depending on computer speed, this might take a second.
It's about 12:24 and 8 seconds p.m.
Oh, we're not talking to you, Alexa. Before you ask, yes, my Alexa's work phrase is from Star Trek. All right, so we have our flow accumulation layer, and we can start to see some really cool figures. So we can start to see some streams showing up through just a simple elevation layer. So then, we just have this elevation layer, and we've already been able to pull out some streams in this flow accumulation. So that's pretty cool. Let's move on to 4. So then from the flow accumulation raster, you can now begin to delineate the stream network. We do have information on that process under the identifying streams network link, but we're looking for a threshold value delineating the stream network of 15,000. So to do that, we're going to use our con tool. So con, spatial analyst tools. And our conditional raster is going to be flow accumulation. We're told that we want a threshold of 15,000. So we're going to set our syntax for this to be where the value is greater than 15,000. We know it's greater than because of the identifying stream networks page. So we've got our sets right here. And we were on 4. All right. So then we go back to geoprocessing. So we have our value is greater than 15,000. Our true raster is going to be our flow accumulation. And let's change the output raster name again. So then this can be our conditional flow accumulation. Run it. And if we did this correctly, we should just have the streams set for our new layout. So then once we've got this stream network delineated, we can order our streams using the stream order tool. So then let's search for the stream order tool. And let's use the stream order spatial analyst tools. Our stream raster is going to be our conditional flow accumulation. Our flow direction raster will be our flow direction raster. And let's change the output of this stream mode. It's kind of cool. So I mean, this is just going to be stream order. We can leave our method of stream ordering to the default, and then we're good to run this. I'm going to deselect my old conditional flow, so I just have my stream order set up right here. That's the end of 4A and 4B. Moving on to 5. To continue our analysis of this layer, we need to change the type of layer that this is. So we're going to change this from a raster to a vector layer. Sorry, I'm burpy today. All right. So then we're going to be looking for the stream to feature tool. And we're going to use the stream to feature spatial analyst tools. Our stream raster will be stream order. Our flow direction raster will be flow direction. And let's simplify our polylines. Our output polyline feature name. So I mean, just do stream order. So we'll simplify those. Let's run it. And cool. I'll deselect my old stream order. And let's check out the attribute table for our stream order vec. So each of these records represents a line from this layer. And then we're told for B, after converting the data from raster to vector, delete all streams that are not Red Butte Creek. And we're also given a little bit of a hint as to what that looks like. So we have this line that we're kind of following right here. So to start deleting these lines, we can use the select tool, and we can just go here and delete them. We can zoom in a little bit and go to right about, oh no, right about here. That one, we'll delete you. There are some lines that are out in space, so not necessarily attached to our Red Butte Creek line. So if you do wind up having any extraneous ones, you'll know. But if you've done this correctly, you should only have 16 and 21 for your object IDs, or your arc ID even too. So these two lines. So right now, we do have 2 separate records for the same line. So now we're going to use the dissolve tool to dissolve it into one feature. So then let's use our dissolve data management tools. And let's save our edits. Easy peasy. So then our input features for this layer is going to be our stream order vec and stream order vec dissolve. I mean, that actually works. I'm okay with that. I don't want to create multi-part features. And we're good to run this. So then let's check out the attribute table for this one. And all right, we only have 1 record, so we're on track. So then I'm going to deselect the old stream order vec. So I just have my stream order vec dissolve up here. All right, so then moving on to 6. To approximate our flood hazard, we will need to analyze the cost of moving outward from the stream. This is going to require multiple inputs, one of which is the filled elevation raster you created in step 2, and the other is a raster representing whether a given cell slopes towards or away from the stream. So first, we're going to use our fill elevation to calculate the aspect of each cell in our filled elevation raster. So we have our aspect tool up top. We're going to use our spatial analyst tools, and let's do our input raster. So our input raster will be our fill elevation and aspect fill 1. Aspect fill elevation. We can leave the rest of our inputs alone, so we're good to run this. And I see that my line is still blue, so let me just clear my selection really quick. All right, so then now that we've got this set, we're going to use the set null tool to set all of the areas that are flat to null. So we can find the set null tool by going into the command search box and search for set null. We're going to use the set null spatial analyst tools, and we're going to input our conditional raster. Our conditional raster is going to be our aspect fill elevation, and we have flat being -1, so where our value is equals to -1. Our false raster, or constant value, is going to be our aspect fill elevation, and set null aspect 1. Let's set null aspect. Set null aspect. So as long as you have these inputs, we're ready to run it. And all right, so this will be a little check for us. So make sure that you have 359.997 your set null aspect. And as long as you do, we are good to continue on. So then next, we're going to need a raster that represents the direction from each cell to the closest part of the stream layer. So to do that, we're told to use the Euclidean distance tool, but that tool is on its way out. So we're just going to click on there, and let's use the distance accumulation tool. So for distance accumulation, we're going to use our Red Butte Creek that we created in step 5, so our dissolve. Next, we're going to change the environment to match our filled elevation raster. So the environment right there, we can change the extent of the layer right here. And we're going to go down to our fill elevation. And once you've got that set, we're good to run. If you are using an older version of Arc, you won't have these icons, but look for extent, and you should be able to select the fill extent from a dropdown. But once you have that set, your parameters are set. Oh, let me do the output. So then this is our direction. This is our direction. 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 So I'm going to run. And cool. So green is closest, a little bit further, and furthest out. So I do have a number that's really huge right here, but we'll fix that in a second. So that is the end of 6A and B. So 6C. So then now that we've got our two rasters created, our direction Red Butte and our set null aspect, we need to convert them from degrees to radians so we can use them for further analysis. So we're going to use the raster calculator to do that. So we can search for the raster calculator. Let's use these spatial analyst tools. And from here, it's pretty much just going to be a plug and chug. So we have our direction, Red Butte, times 0.0174533. Let's change the output name. This is our direction red B, radian. Let's run it. And I'll deselect my old one. Let's do this one more time for our sentinel aspect. So we have our sentinel aspect times 0.0174533. 533. We'll change the output raster name to our set null aspects gradient. And let's run it. And cool. I'm going to deselect my old set null aspect. And let's move on to step B. So now that we've got our rasters converted to radians, the cost parameter can be created using the following steps. So we're back in our raster calculator. And I recommend copying the little code line that we have here. It'll make your life a little bit easier, and you can just plug and chug. So we have our set null aspect and our direction. So all we're going to do is clear out the aspect. We can double click and repeat. So there's my direction. Same thing for my aspect. And I'll do the same thing for my direction. So we should have our aspect, direction. Let's change the output raster name to something else. Oh, this is cost. So cost, and we're good to run. So right now we have 1 and -1 is our values, and we'll change those in a second, but there is one quick step that we have to get through before we move on. So we're told to use the isNull tool and use the raster that we created from 60i, our cost raster, and then use the con tool where the value is equal to 1. And yeah, so let's get started with that stuff, that part. So isNull, and let's go isNull, spatial analyst tools. Our input raster will be our cost, and isNull cost 1 makes sense to me. So then I'll run that. And then we have our 0, 1s. And then following that, we have our con tool for our conditional input. Our input conditional raster will be our isNull cost 1. And we're told that we want where the value is equal to 1. Our true raster is going to be our isNull cost 1. Our false raster will be 0. The output raster that we're going to use can be conditional cost. Right? And all right, we have another 0, 1. So then finally, for us to be able to use this, we need to turn all of our values positive. So to do that, we're going to go back to our raster calculator one more time. Oops, raster. Analyst tools, we have our conditional cost plus 1. Let me rename the output raster. Cost. And we get to run this. And all right, now we have our 1s and 2s. So then next, following that, we're going to run the path distance tool. And so then we can find our path distance tool up top, but I think this tool is also going out. So let's use the distance accumulation tool. Our input raster is going to be our one from 5BI, so our stream dissolve. Our surface raster will be our fill elevation raster. Our cost raster will be our conditional cost 1. And those are the inputs that we've got for this one. So then let's run it. And all right, this is our output. We have 341.568. But yeah, this looks nice. So then we have our Red Butte Creek Dam up here, and all of this could be flooded. But we have further to go before we can actually say that. So then moving on to 8, we're told to create a polygon representing the watershed for Red Butte Creek using the watershed tool. The watershed tool requires 2 inputs, the flow direction raster and the Red Butte Creek line feature. So we could search for our watershed tool. Let's use the spatial analyst tools version of this, and we have our direction, flow direction. Our input raster is going to be our Red Butte Creek line. And let's give this watershed, watershed lab. We're good to run this. All right. So now we have a layer that we can use to extract the values of this watershed from our, oh gosh darn it. I did it with every one except for this one. Moving on. So now that we've got our watershed, let's use the extract by mask tool. Extract by mask. And let's use the spatial analyst version. We check the eyes, the input rasters, the input raster from which cells will be extracted. So that'll be our distance string 1. Our feature mask data will be our watershed lab. And the output raster name, all right, so then I have my mask extract flood risk, and we're good to run this one more time. And now let's deselect our watershed lab, and we have 218.6. So I'm gonna minimize all of these. And all right, so then this is going to be what will be part of your deliverable 1, a map of this feature. You're told to change the symbology of this layer to best communicate this data. So that means you can switch between discrete, classify, intent, unique values. Sure. Oh no. Oh, that's a cool feature though. I wonder what these are based on. Oh, that's cool. But yeah, symbology. There you go. Oh, that's kind of cool too, actually. I like the shaded relief. But yeah, so sorry. So you have all of your areas and all that good stuff. So find the symbology that best matches up with what you want to communicate. Include all of the usual map stuff. And finally, include some additional data that might increase the accuracy of this analysis. And why might displaying the flood hazard for only the watershed be a limited choice for the specific scenario? Keep in mind, well, actually, yeah. So keep in mind, this is flat down here. So we have high mountain walls and a dam breaking. So, I mean, we'd definitely get some spillover over here as well. But just things to think about. I hope this helped. Thank you all for tuning in, and I will see you all on Thursday. All right, bye.